This is section 7.1. We're going to simplify only today. We'll pick up on more difficult parts tomorrow. All right. We're looking at a rational expression. A rational expression is a ratio or a fraction of two polynomial expressions. So there's a second degree polynomial, my example, in the numerator, and a first degree polynomial in the denominator. Now, what we mean by simplify is we're going to factor these things and we're going to reduce the fraction. Kind of like if I had 6 over 4, I could write that as 3 times 2 over 2 times 2, right? So 6 is the same as 3 times 2, 4 is the same as 2 times 2, and I can reduce the fraction, right? Cancel the 2's and I have 3 over 2. That's what we're going to do with these polynomial expressions. Now, something else we're going to do with these polynomial expressions is we're going to identify the excluded values. The excluded values are going to be the values that make the denominator equal to 0. And we're going to identify that before we reduce. Because even if we're able to reduce the problem factor, we still consider them excluded values. All right, now, I have a different version of the note sheet. I forgot to bring it home, so I had to print an old one. So if this problem is a little bit different from yours, you can pause the video and copy this one. Otherwise, hopefully it's the same problem. All right, so what we're going to do here is first thing we're going to do is factor out the numerator and denominator. So in the numerator, there's a common factor of 6. Right? This is the most missed factoring problem where people don't factor it out a common factor. Okay, in fact, that was a problem on the last test. So we take out a 6, and it's 7b plus 2, right? 6 goes into 42 7 times. 6 goes into 12 twice. We're going to do something similar to the denominator. There's a common factor of 6 again. All right, so that's going to be 2b plus 3. All right, now what we want to do is identify the excluded value. Remember, the excluded value is whatever makes the denominator equal to 0. So what we're going to do is set each factor that can be 0. Like 6 can't be 0, so we're not going to bother to set that equal to 0 because it can't be 0. So we're only worried about the 2b plus 3. So we're going to do 2b plus 3 equals 0 and solve that equation. So I'm going to first move the 3 over, so you subtract 3 from both sides. So that's 2b equals negative 3, divide by 2, and I get b equals negative 3 halves. So this is an excluded value. This is an excluded value. This value for b is not part of the domain of this expression. Okay, that's an excluded value. Excluded value. If you don't write those words out, I'm okay with that. Just circle it. All right, now we're going to simplify this. So we always pick out the excluded value before we simplify. Okay, now we simplify. What simplifies here is that the 2 6's cancel or reduce. So we say final answer without the common factor, right? We got rid of the common factor, and that's what that is. All right. So there's 2 parts to this answer. One is the reduced fraction and the excluded value. B, we're going to do the same thing here. So I do not like having a leading coefficient that's negative. And by the way, I've noticed that about whenever a student leaves a negative coefficient, 85% of the time they factor it incorrectly. So I recommend that you, hold on, my computer's going to act up. All right, nope, stop. All right, so I'm going to take out a negative. So it'll be 5k squared minus 9k plus 4 over, I'm not going to change the bottom. All right. Okay, now we're going to do the Lizzie method for both the numerator and denominator. Okay, let's move that over, give us some space here. So the numerator is going to be 5 times 4 is 20. Got to combine to make negative 9. So I'm going to think negative 5 and negative 4. Right? Negative 5 times negative 4 is positive 20. Negative 5 plus negative 4 is negative 9. And don't forget with the Lizzie method, we have to divide by the leading coefficient. Now, so the leading coefficient is 5, not -5. It's 5 because this negative is outside of the trinomial now. So we'll just divide by 5 and k minus 4 over 5. All right? So this minus 5 is that minus 5. This minus 4 is that minus 4. The 5's in the denominator is that 5. This negative is not part of the polynomial. All right? But it should still be part of the problem, so don't ignore it completely. Okay, we're going to do the same thing to the denominator. 7 times -9 is -63. What are the factors of -63 that combine to make 2? That's going to be 9 and -7. Right? 9 times -7 is -63. 9 plus -7 is +2. So that's going to be it. So it's k plus 9 over 7, right? The leading coefficient is 7, so I need to put that in the denominator. And k minus 7 over 7. All right, now I'm going to simplify things. Oh, well, I'm going to clean it up. So that negative sign is still part of the problem. K minus 1. And this, remember, if you have a fraction, try to reduce it. 4/5 does not reduce. I'm going to move the 5 forward. So it's 5k minus 4. And 9 over 7. So that'll be 7k plus 9. And here, 7 over 7 is 1. K minus 1. All right, so first thing we're going to do is find the excluded values. We're not going to reduce yet. I know some of you want to reduce now, but wait till you find the excluded values. So my excluded values is going to come from the denominator. 7k plus 9 equals 0. K equals -9/7. And k minus 1 equals 0. K equals 1. Hopefully you can figure out how these are solved. These are only linear equations. Make sure you can do this. If you cannot solve these equations, make sure to get help. Otherwise, I'm going to assume you know how to solve a simple linear equation. Right, so we have two excluded values. K equals -9/7 and k equals -1. All right, and then we're going to cancel these out. Now, final answer is going to be -5k minus 4 over 7k plus 9. All right, that's it. I'm going to do a couple problems from homework, I think, although I don't think we need to. All right, I'm going to do number 1. All right, so here, I'm going to factor the numerator. Well, here, the denominator is already factored. So what makes the denominator equal 0? Well, you just do 6 minus n equals 0. That means you get n equals 6. Right? N equals 6 is the excluded value. You don't have to worry about anything else. But now we've got to simplify it. So that's going to be n. So what are the factors of -12 that combine to make -4? That'll be -6 and +2. 6 minus n. Now, here's the weird part. You got an n minus 6 and a 6 minus n. When those two reduce, they can reduce, but the problem is there's a difference. And then let me rewrite this a little bit. So it's n minus 6 on top, n plus 2. And I can rewrite this as -n plus 6. But all I did was reorder it, right? But it's still not exactly the same. What you can do is factor out a -1. And when you factor out a -1, it changes the signs and makes it look like the 1 on top. So I can now reduce those. So that's now the negative of n plus 2. So final answer, n plus 2 with a negative sign outside. Okay. So my excluded value is n equals 6, and my final answer is negative of n plus 2. All right, that's it, I think. I'm going to do one from the back. Sure, I'll do one from the back. I'll do, let's do 14. All right, so here, factor the numerator. If you factor both numerator and denominator, so it's going to be v plus 4, v minus 2, and the denominator is v minus 2, v plus 1. Hopefully you can figure that out, right? Just regular factoring. Sorry, my Discord is blowing up. I don't know why they're so busy tonight. All right, now, So first find the excluded values. My excluded values are v equals 2 and -1. Those are my excluded values. Now reduce. So you just have v plus 4 over v plus 1. And that's it. Good night. Shut these people on this.